Hi there. Okay, we have a super easy lesson today on on synthetic division. What did I do? There we go. Maybe I'm back. Maybe. Somehow I got to the end. Okay, super easy lesson on synthetic division. So by the end of today's lesson, you should be able to do long division when you have a divisor in the form x minus b. So no coefficient in front of the x, but if you have like x minus 4, x minus 6, or x plus 2, you can use this super quick method of synthetic division to do your long division for you. So it doesn't replace long division because you have to use long division when you have something like a divisor like 2x minus 1, but it is just something to have in your back pocket on a test or even in your homework for some of the questions that require long division. You will be expected to know long division. I will ask you specifically to use long division on a test because you are expected to know it, but in other instances where I don't say which method you need to use, feel free, if it's appropriate, to use synthetic division. Okay, so here's the method. It's kind of long and protracted here, this note, but it's a super easy method. So what you want to do here is you want to take first of all, put your dividend in descending orders of power again, and the same rule applies about the placeholders. So if you're missing one of your exponents, make sure you put a placeholder term in. So if this is our dividend here, we take the coefficients of each of the terms and we write them here. And then we do this little upside down division symbol. So usually we're going the other way, but this time we're going this way, and we're leaving a little room because we're putting numbers here. Okay? And then what you do from there on in is you look at your divisor and you take this number as is. You do not change the sign, you take it as is. And you put it to the left of your numbers. Okay? And you're going to put a division, not a division sign, you're going to put a minus sign below it. Okay, so we're all set up to do our synthetic division. We took our coefficients, these are in order. We took our negative b, if you will, because b is if you take the opposite sign, but this is really the negative b. And we're going to get started. And we're going to put a little multiplication sign in the lower part. First step, bring the first term down. This kickstarts the process. And then you're going to multiply negative 1 times 1 and put it here. So of course that's negative 1. And then you're going to subtract 5 minus 1. Well, that is 5 plus 1, which is 6. Then you're going to repeat. Negative 1 times 6 is negative 6. And 6 minus 6 is 12. Okay, and you're finished. You ran out of numbers. Okay. So let's just see what it says. Multiply the top left number, negative 1, by the lower number 1, and you get your next number, 6. Sorry, negative 1. Subtract the two numbers and you get your negative 6. Place the answer below the division sign. Repeat this process until you get the numbers. Okay, now here's the new part. The numbers that you get down here are actually the coefficients of your quotient. So the way you do that, I hope I have it on the next page. Let's see. No, I don't, so I'll go back. The final number is the remainder. So what you want to do once you've finished is you want to work backwards from right to left to associate the correct variables to the coefficients that you've got. So let's go back and look at that. So our answer here is this is remainder 12 because that's the remainder. This is our constant term. So it's 6 plus 6. This is our first term. with an exponent of 1, but we don't write that, right? So x to the 1, and then our constant term, and then our remainder. So this is our quotient, x plus 6, remainder 12. So when I divide x squared plus 5x plus 6 by x minus 1, I get x plus 6, remainder 12. Okay? Let me just make sure that I've answered that question. It didn't ask for it in a particular form or anything. It just says divide them. Okay. Okay, so I'll put it in quotient form here. So I'll say x squared plus 5x plus 6. I'm getting that from here, right? If I go backwards, this is the constant, this is the x term, this is the x squared term. Divided by x minus 1 is equal to our quotient, which is x plus 6 plus our remainder, which is 12, divided by our divisor, which was x minus 1. Okay, so that's one way of expressing that answer. The other way would have been in corresponding form. I'll just write quotient form here. Okay. All right, that's synthetic division. Super easy, huh? So let's just practice here. I want you guys maybe to try it and see if you can get it, and pause the video, and then I'll weigh in with my answer and we can compare. So once we do all of the multiplying, so I brought the 3 down, that kick-started things. 4 times 3 is 12. 7 minus 12 is minus 19. 4 times minus 19 is minus 76. 2 minus 76 is 78. 78 times 4 is 312. Minus 4 minus 312 minus 316. Then we start again. 4 times negative 316 is negative 1264, and 5 minus 1264 is 1269. I think I didn't use a calculator, so if I got something wrong, let me know tomorrow. Okay, so what does all this mean? This is our quotient here, and we work backwards. This is our remainder. So this is our order 0 term, or our constant term. This is our order 1, this is our order 2, order 3. So this is the coefficient of them all. So this is 3x cubed minus 19x squared plus 78x minus 316, remainder 1269 is our answer. It asks for it in quotient form, so I'm just going to say where's our answer? Our questions: 3x to the 4th, minus 7x cubed plus 2x squared minus 4x plus 5 divided by x plus 4 is equal to the quotient 3x cubed minus 19x squared plus 78x minus 316 plus our remainder, which is 1,269 all over x plus 4. Alrighty. Is there a way we could check that? Because that's pretty nasty. Any ideas? Anybody? How about what it says here? Check your answer using the remainder theorem. So, on a test, if we get funny looking numbers like this, we could check just to see if we get the same remainder, because that would be, if we didn't, of course, that's a huge red flag. So let's go ahead and use the remainder theorem. So we know that let me just, here, I'll do it in red or something. So we know that our A is 1 and our B is -4 here. So we want to find P of -4. Right? It's P of B over A, which is P of -4. So P of -4, when I put that into my P of x, would be 3 times -4 to the 4th minus 7 times -4 cubed plus 2 times -4 squared minus 4 times -4 plus 5. All right, well, let's see. This is going to be positive, and then 4 squared is 16, 64. 64 times 4 is 256, and 256, this is where I'm going to have to cheat, times 3 is 8, carry the 1, 15, 16, and 6, 16, 768. So I'm just going to move up here. So P of -4 is, I believe, 768 minus plus, because this is going to be a minus, and then a minus here is a plus. So this is 64 times 7, 8, carry the 2, 44, 448. Plus 32 plus 16 plus 5. Wow, lots of adding there. So it all gets added up. So this is 21, 53, 501, I think. 53, 501. And if I add 501 to this, I get 9. 101. So 501, 6. Yeah, baby, look at that. All right. So we got the, we know that we very likely got the right coefficients here in our final answer. Okay. Let's see what the second one is. So the second one here is very similar. You're just going to put a placeholder in. As you can see, we're missing the squared term. So go ahead, put the 0 in as your coefficient of the squared term, and do synthetic, that's hilarious, synthetic division, just like you did in the previous example. Just pause the video and come back in when you're done. Okay, so I'm getting a remainder of negative 134. I've got a constant term of negative 46, an x term with a coefficient of negative 15, and our x squared term has coefficient of negative 5. So if I'm doing the quotient form, I'm going to write the original question without the placeholder, show the division. So that's what we were asked to do. We used synthetic division, and we got an answer of minus 5x squared minus 15x minus 46. That's our quotient minus 134 over our divisor, which was x minus 3. Now, for some reason, I'm not feeling too comfortable about that answer. I don't know why. So I am just going to check using the remainder theorem. So if we do that, I'll switch colors, and I'll say my A is 1 and my B is 3. So P of 3 is what I want to find. And so if I'm finding P of 3, I'm going to say minus 5 times 3 cubed minus 3 plus 4. All right. When we calculate that, 3 cubed is 27. 27 times 5 is negative 135 minus 3 plus 4, which is negative 135 plus 1, which is negative 134. And so I'm feeling much better now about my answer. Okay, that is synthetic division. So let me just quickly review. You bring down the first number, you multiply the number on the outside by that number, you put it here, you subtract, you repeat, put it here, subtract, get that here, repeat, multiply these two together, put it here, subtract. Okay? All right, just takes a little practice. You've got a worksheet to do. It's not your homework. It's a worksheet that you have to print off for section 2.2 synthetic division. Good luck. Sorry, my mouse isn't working to stop the video, but you can certainly stop.